Alright guys, so today we're basically going to summarize all three main methods of solving a system. So again, that means solving by graphing, by substitution, and by elimination. Alright, so we're going to begin real quick by summarizing in steps here. So solve by graphing. So what do we have to do first? If you remember, if I want to solve by graphing, it's nice if I write it in slope-intercept form. So write your equation, write in y equals mx plus b. Okay, well, the second thing that I need to do is, well, once it's written, both of them are written in y equals mx plus b, I need to graph the first equation. Okay, so let's say the first equation was y equals negative 2 over 3 x plus 4. All right, let's say that was the first equation here. So again, I want to go, here's my coordinate plane. I want to start off at my b. Remember, don't forget, b is your y-intercept. So that is the y-intercept. I'm going to go up 1, 2, 3, 4. That is my first point. Okay, next thing I have to do is I have to use my slope. Now, because my slope is negative, I'm going to have to go down 1, 2 over 3. So I go 1, 2, 3. So down 1, 2 over 3. Okay, and we drew our line. Okay, well, graph the first equation. I also need to graph the second equation. And again, that's the same way. Whatever that second equation was, let's say it crossed and it came down something like that, blah, 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 right? Well, I want to find my solution. Remember, your solution is at x, comma, y point, that part where they intersect. So in this case, these guys actually cross right there. So that x, comma, y is my solution. In this case, let's go 1, 2, 3. That's 3, comma, looks like 1. So 3, comma, 1. That is my solution. All right, so let's move on to substitution. Well, if I want to solve by substitution, you have to isolate, number one, isolate a variable. What that means is just get a variable by itself. Okay, once you have that, you're going to substitute into the other equation. And then you're going to have to solve a multi-step with, distributing, combining like terms. Okay, solve a multi-step to get one variable. Again, that's just going to give you your x or your y. And then you have to plug back in to get your actual solution, to get your solution x, comma, y. So again, what that looks like, let's say I give you the system y equals 2x minus 3, and I give you 4x plus 6y equals 11. Remember, I know what y is, so I'm going to take what y is here, and I'm going to literally plug it in for, this is my second step where I substitute, so I end up with 4x plus 6 parentheses 2x minus 3, 2x minus 3 equals 11. And again, this is where you solve the multi-step equation. You distribute, you combine like terms, you go all the way through, and you get x equals blah, blah, blah. Once you have your x, you substitute back into your original to get your y value. And again, your solution is at x, comma, y. All right, well, what about elimination? Well, it's in the name. You have to eliminate. So pick a variable. Pick a variable to eliminate. Again, that could be x, that can be y. It's up to you. Okay, and remember, this is where you have to give one of them a makeover. So give an equation a makeover. So again, this is where you distribute by something. So remember the way that we cancel them out. If I have a 5x, what's going to cancel that out? Well, it has to be a negative 5x. And of course, you're going to have the rest of it equals something, equals something. These guys cancel out, and you combine your like terms. You can go on x equals or 4x equals blah, blah, blah. Okay, so then you have to solve a 1 step equation. And then you plug back in to get your solution. Remember, that's that x comma y again. Don't forget that. That's very important. All right. So now these next few examples here, guys, you've seen them before. What I want to answer, though, is what method should I use? What's going to be the most convenient? So again, from this point forward, you can pick whichever one you want. So if I take a look at this one, I notice that they're both in standard form. My x's are lined up, my y's are lined up. So my best bet here is going to solve by elimination. The nice thing about it, if this is a negative 4y, if I want to cancel the y's, this up here has to be a positive 4y. How the heck do I make this a positive 4? Let's give it a quick makeover. Let's distribute everything by a 4. So what does that become? Well, this becomes 4 times x is 4x. 4 times y is positive 4y. 4 times 20 is going to give me 80. And again, the bottom was going to stay the same. X minus 4y is equal to negative 15. And of course, from here, the y's cancel out. You're left with 5x, blah, blah, blah. Okay, and you would keep solving from there. Now again, this is going to be the easiest one because all you have to do is distribute by a 4 to cancel out your variables. So again, that would be the best approach for this one. Now what about for this next example here? I have 2L plus 2W equals 94, and I have L is equal to 2W plus 2. Well, they're not both in standard form. The nice thing, though, is, hey, L is all by itself. Why not use substitution? I know that L is equal to all of this here. Let's take this and let's substitute in for the L in the first equation. So what I really should have here is I have the 2 from the first equation, parentheses. Well, what's L? L is actually 2W plus 2, which is what's here in red, plus 2W is equal to 94. And of course, you'd go through the motions here. You distribute, combine like terms till you figured out what W was. And again, once you know what W is, you plug back into whichever equation you want. So again, elimination might not be the best for this one. I would use substitution because I know what L is. I already have a variable all by itself. All right, the last one here. Hey, they're both standard form. I can easily cancel out the x's or the y. It does not matter. I think the easiest one right here would be the y's. Notice if this is a positive, this one should be a negative. So why not multiply just by, hey, by negative 1. Remember, distribute to everything. This becomes a negative x. Oops, not plus anymore. This actually becomes a minus 5y is equal to negative 25. I get 3x plus 5y is equal to 40. Now again, the reason I did that was so that that plus becomes a minus, right? These actually end up canceling out. You get 3x's minus 1x is 2x equals blah, blah, blah. And again, you go through the motions. You get x equals something, and you substitute back in and solve. So again, that would be the easiest, quickest, most efficient way. So you always want to say, hey, which is the best approach? So again, why did I do this? It's because, hey, they're both in standard form, and I can easily cancel out the y's here. All right, so let's actually get into an example that will solve all the way through. Now, the trick behind this one is there's nothing I can really notice. They're both in standard form. I do want to use elimination here, but I can't multiply 2 by something to get kind of that negative 3. It's not going to be that easy. Same thing with the 4. So what I actually have to do is I actually have to give both of these guys a makeover. If I want to get rid of the x's here, I have to make these both be the same thing, but just kind of opposite signs. So 5x and 4x, what can I get both of these guys to become that when I add them together, I get 0 x's? I get them to cancel out. Well, you have to multiply by the least common multiple. So if I multiply by 4 and the bottom one by 5, let's see what happens here. What's 4 times 5? Well, that's 20x. What's 5 times 4x? Well, that's 20x. Now, I was close. These don't cancel out. That would give you 40x. How can I get these to cancel out? Well, let's just make one of these, and if they don't bother, you can make whichever one you want. I just chose the top one. So this is actually negative 4 times 5 is a negative 20. 5 times 4 is positive 20. These guys will actually end up canceling out. So here's the trick behind this one. It's still elimination, but I'm giving both of these guys a makeover. The top one's going to get multiplied by negative 4. The bottom one's going to get multiplied by positive 5. So when I distribute here negative 4 to all of these pieces, I get negative 4 times 5 is negative 20x. Negative 4 times 3 is negative 12y. Negative 4 times 2 is negative 8. Bottom one's going to become 5 times 4, which is 20x, which is nice. They'll cancel out in a second. 5 times 2, which is positive 10y. 5 times 10, which is 50. Alright, so what happens here when I add these guys together? 20x and minus 20x cancel out. Here the y's give me 10y's and negative 12y's are going to give me negative 2y is equal to 50, and negative 8 are going to give me negative 42. If I divide both sides by negative 2, I get y is equal to negative divided by, oops, wait, how did I get a negative here? This actually should have been a positive 42. Oops, I messed up there. 50 minus 8 is a positive 42. So 42 divided by negative 2 is going to give me negative, what is that going to be, 21. Okay, so I know my y value is negative 21. How the heck am I going to get the x? Let's take that and plug it back in. Now I'm just going to choose the second one. Why not? I get 4x plus 2y is equal to 10. If I plug in negative 21 here for the y value, well, I get 4x. Now this becomes negative 42 is equal to 10. If I add 42 to both sides, I get 4x is equal to 52. Divide both sides by 4. I'm going to get x is equal to 13. Okay, so I know my x, I know my y. My solution is 13, comma, negative 21. Okay, that's what I need to box in there. All right, what I want you guys to do is try this next example. So pause the video right here, and then we'll resume together. All right, guys, so here's the trick for this one. Notice both in standard forms. I'm going to choose elimination for this one. Now, I didn't have to give both of them a makeover unless you're trying to eliminate the y's. If I want to get rid of these x's, if this is a positive 10x, this has to be a negative 10x. Hey, that's a quick fix. Let's multiply this guy by, yes, negative 5, because negative 5 times 2 is going to give me negative 10x, which will cancel out in a second with this guy. Negative 5 times 5 is negative 25y. Negative 5 times 22, well, 22 times 5, 2 times 5 is 10. Again, 10 plus 1 is 11, so I get 110, and it's actually going to be negative 110. Okay, the bottom one has to stay the same because I'm trying to cancel out the x's here. Plus 3y is equal to 22. All right, so what's going to happen here? This is going to cancel out. I get 10x's, negative 10x's cancel out, which is nice. Negative 25y and positive 3y give me negative 22y is equal to negative 110, and positive 22 is going to give me negative 88. Okay, if I divide both sides by negative 22, negative divided by negative is a positive. That's going to be 4. Y is equal to 4. Awesome, I have y. I need to figure out what x is. I'm going to choose, I'm going to be lazy with this one and be smart about it. I'm going to choose the first one. It looks like I have smaller numbers here. So I have 2x plus 5y is equal to 22. Well, I know what y is, so I got to plug it back in. I have 2x plus 5 times 4 is equal to 22. All right, well, 5 times 4 is 20. Oops, that should be a plus sign there. If I subtract 20 from both sides, I get 2x is equal to 2. Well, divide both sides by 2. X is equal to 1. My solution is 1, 4. All right, guys, I'm running out of time here. So what I want to do is pause the video here. I'm going to make a part B to this. So we can go to part B or part 2, whatever you want to call it. Go to part 2. All I have left is a quick reflection and then your class activity in the next section. All right, should not be longer than 5 minutes. So again, I'll see you guys there in a second.